Hey, how y'all doing today? I'm gonna work on some percents, and gonna have a quiz later this week over percents and scientific notation. We'll practice it quite a bit before we take it. This problem here, an item's original price is $40. It's marked 20% off. Find the new price. So we have to keep our eye peeled for words I have circled, okay? On the other side, I didn't circle the words. Instead, I underline them. So those are different kinds of problems. So I circled off and up, things like that. So what we want to do is take our 100%, and we want to subtract our 20%. And that's 80%. Now that needs to be divided by 100 so we can put it into the original times percent equals new equation. So that's 0.8. Now I come up and set up my three spaces. Blank times blank equals blank. So we have original first, and that doesn't change. And then we have our percent, that doesn't change. And then the new. So I know the percent I'm going to put in is 0.8. I have converted the percent into a decimal. And now I go circle the last sentence, and it says find the new price. I'm going to put X under that. And I see the word new, so that means X is a new price. That's my answer to the problem. And my original price must have been the $40. It even says it. The original price is $40. So I perform the operation, okay, that I see. 40 times 0.8, and that's going to be 32. So X equals $32. So what they did, prove was $40 is marked 20% off, and now you're paying $32. That makes sense. Okay, the next problem. An item is marked up 40% from its original price. The item's new price is $77. Find the original price. All right, so again, there's that word up. Well, that indicates the percent has changed from 100%, and then we add 40. Then it ends up at 140%. Now we want to divide that by 100. Don't forget that. That's 1.4. Okay, so again, blank times blank equals blank. And same order, original, percent, and new. So we know our percent's 1.4. Now I'm going to circle the last sentence. Find the original price. So it's an X. Well, it says original, so that means the X variable goes for original because that's what I'm trying to figure out, and that the new price was $77. So I can't do the operation of times because I don't know what X is, so I need to do the opposite of what I see, which is divide. So I'm just going to kind of connect the lines here and put 1.4 somewhere under there, and those cancel. And then I divide the other side by 1.4, so I divide 77 by 1.4, and I get 55. So X equals 55. Because remember, I didn't know the original. So the original price is $55, and it's marked up, and then it ends up as a new price of $77. This will work every time if you put the variable in the right place. Item's original price is $300. It's marked up 20%. Find the new price. So the word up indicates I need to take 100% and add 20%. 100 plus 20 is 120%. And I want to divide that by 100, and that gives me 1.2. So I go to my old reliable. Blank times blank equals blank. So I have original, percent, and new. Okay, so we know our percent is 1.2. We can put that in there as a factor. And then it says the last sentence, that's your X. Find the new price. Okay, so again, I don't know the new. And the original price was $300. So again, there's equals. So I see the two numbers and I see the operator's times. So to find X, it's very easy. 300 times 1.2 is 360. So X equals $360. So I had an original price of $300 and it's marked up 20%. And it's going to equal a new price of $360. You kind of look at your equation and know whether, it makes sense or not. Okay, an item is marked 40% off its original price. The new price is $30. Find the original price. So again, I see off. So I take 100%. It's off. That means we subtract 40%. And that's 60%. Okay, so blank times blank equals blank, and we have the same three things: original, percent, and new. So I know, oh yeah, I need to divide that by 100. I forgot, my bad. 60 divided by 100 is 0.6. So 0.6 is the percentage. Okay. All right, now let's circle the last sentence. That's what I don't know. It says it's the original price, so that's X. So X is my original, and $30 is the new. Now I look in that equation. Well, I can't multiply because I don't know what X is, so I'm going to connect the line, and I'm going to just put a 0.6 underneath, and then those factors cancel. And then I put a 0.6 on the other, just below the other one. That means I need to divide. I need to take $30 divided by 0.6. And that's 50. Now again, makes sense because we had an original price of $50, then percent was taken off, and I multiply by 60, and we end up with a new price of $30, okay? If it's off, if it's off, whatever's here, which is 50 now, that should be bigger than here. When it's up, whatever's here, which was 55, should be smaller than here than what you ended with. Okay, now let's look on the back side. 30% of the school attended an assembly. There are 200 students in school. How many students attend the assembly? Now, the first thing I see is there's nothing circled. That's because we don't change the percent. Okay, we're not going to go over here. So what I do if it's not a change in percent is I put 100% and then I put a line over the top of it and I make a ratio out of it with the percent from the problem. Equals, and what this is known as is part whole. You can put P and W if you want to abbreviate. It's always part over whole. Now we need to define the part kind of right here because that's my top. Now I've defined the part for you. They attended an assembly, so I'm going to write attended assembly. And you can write that however you want, but it's important. You got to know what the part stands for. So now I go circle the last sentence. You kind of have to go down here because the sentence extends past the line. That's where X is at. Now remember, the part is attended the assembly. In that circle, does it say anything about attending the assembly? How many students attended the assembly? Yeah, it does. Attended the assembly. So the X is the part, because that's where attended assembly goes. And then the 200 then is my whole. So I need to find the part that attended the assembly. So it's easy. I just cross multiply and divide. So I'm going to take 30 times 200 and divide by 100. and I got 60. Okay. Now, if you're wondering about a label, it was 200 students, and the 60 is students as well. Okay, the next problem. 25% of the land in the United States is covered by forests. The forest covered 2,000 square miles. How many square miles of land are in the United States? So again, there's not an up or an off, so I don't mess around over here. I put 100%, put a line over it, it's 25%, then I make a proportion out of it. It means two equal fractions. And that's part whole. Now we need to define what part means, okay? Now I defined it, it's covered by forest. Okay, that's why I underlined that, so you know what part means. So now let's circle the last sentence. How many square miles? The whole sentence. Remember, the part is covered by forest. Does it say anything about forests in that last sentence? I don't think it does. Okay, remember, this is X. Okay, I don't think that says covered by forests. So the X will not go here. It will go here. I'm trying to figure out the whole. The 2,000 in the problem is the part, and that's kind of apparent because it says forests cover that. So 2,000 goes here. So I cross multiply and divide. I take 100 times 2,000 divided by 25, and I get 8,000. Okay. Okay, it's 2,000 square miles, so it's 8,000 square miles. When you're doing part whole, the labels will be the same on these two. Okay. Now, I didn't know X, but now I know it's 8,000. It'd be 8,000 square miles. Okay, now my next problem. I spend 30% of my monthly paycheck on rent. I spend $600 of my paycheck on rent. How much money is in my paycheck? Again, this will not be a problem where I go over here and add or subtract. So, got 100%. I want a line over it. Now above it, I put the percent right there. It's going to be a cross. Again, they're different from these. These we want to write out an equation. These I want to write out a proportion. Okay, I want to end up doing cross multiply and divide. Okay, and P and W, put a little P right there, and we got to define what the part means. It means rent, so just put on rent. Now, let's figure out what goes where. You got to circle your last sentence, and that's X. Just put it in one of the two circles because you had to go over here. Now, it says on rent. Does this sentence say anything about rent? How much money is in my paycheck? No, it doesn't. Okay, so the X will not go here. It will go here. I'm figuring out the whole. And the $600 is what I spent on rent. Now I'm trying to figure out the whole. So again, I cross multiply. Take 100 times 600 divided by 30. 2,000. Now, if you're wondering about the label, well, 600 is dollars, so 2,000 is going to be dollars. Okay, next one. 60% of the animals at the zoo are reptiles. The zoo has 200 animals. How many reptiles are there? Okay, again, I don't want to mess around with the adding and subtracting to 100, so I'm going to put 100. And I take the percent from the problem, 60%. And I make a proportion out of it, part over whole. So the part is defined by reptiles. So reptiles. Okay, let's circle the last sentence, because this is what I'm trying to figure out with an X variable. Now the part's reptiles. Does it say reptiles in that sentence? Yes, it does. So I will be putting the X here, Now I'll be putting the 200 as my whole. Okay, I'm trying to find the part of the whole that's reptiles. I know the whole is 200. So I cross multiply and divide. 60 times 200 divided by 100. And I got 120. 120 what? Now the 200 is, just put reptiles. Forget that. Don't worry so much about the label. Okay. 120 animals were reptiles. You can put animals. If you did, I wouldn't hold it against you. But what you just figured out is 120 animals that were reptiles. There's 200 whole animals, 120 reptiles. Okay, and hopefully that gives you a little better understanding how percents work in the real world. Okay, scientific notation. We can put the calculator aside now. We're not going to need that. Now, you might not like how I do this. That's fine. What I'm going to do first, remember there's 3 steps before we really do anything else. Number 1 is go find your decimal and circle it. So the decimal's right here. In the next problem, I don't see a decimal, so it's at the end of the problem automatically. Next problem, I don't see a decimal. It's at the end of the problem automatically. In the next problem, the decimal's here, so right there. In the next problem, the decimal's here. In the next problem, I don't see the decimal, so it's right here automatically. In the next problem, the decimal's here. In the next problem, the decimal then is at the end automatically. So we need to know where our decimal's at if we're doing scientific notation. Okay, now, next thing. We need to identify the first number that is not 0 starting at the beginning. So 0, 0, 0, 0, 3. I'm going to mark the 3. Okay, from the beginning, we have a 4 right away, so I mark that. Here we have a 5 right away, so I mark that. Here we have 0, 0, 0, 0, 0. So, and then I got a 7. I mark that with an arrow. 0, 0, 0, 0, 3. I'm going to mark the 3 with an arrow. Okay, right away we have a 7, so that'll work. 0, 0, 0, 0, 0, 0, 7. That'll 7. And right here I have a 5 right away. That'll work. Okay. Now, next part is probably the worst part. You need to figure out if you need to move the decimal. And the reason you mark this number is because you want the decimal to come after that number. Okay. You want it to come after that number. Decimal needs to then go between the 3 and the number that's right next to it, right to the right of it. Okay, it's got to go right here between these two, right here. Now, to move that decimal right here, you would have to move to the right. Okay, so you write right, and then when I write it in scientific notation, the exponent's always negative. Okay, now here's a number we marked. We want the decimal then to go between these two. Okay, the number I marked and the number right after it. To accomplish that, I'm going to have to move the decimal this way. It's right here. I'm going to have to move it this way. This is left. So if I'm going to move the decimal left, then when I write it in scientific notation, it's going to be positive. Okay, remember I need the decimal to go between the number I marked and the number right after it, right here. Well, here's a decimal. To have that happen, it has to go to the left. So it's left, and that means the exponent that I write is going to be positive. Okay, now here's my decimal. I mark this number, so it's got to go between these two. Well, for that to happen, I go to the right. Okay, this is right. So right, that means my exponent's got to be negative. Okay, I want the decimal to go after this number between 3 and 2. Okay. And for that to happen, we go to the right. That means my exponent has to be negative. Okay, next problem. And I'm going to go back and write these answers here. Here's my decimal. I need a decimal to go between the 7 and the 0. Okay, 7 and the 0, the number I marked, and then right after it. For that to happen, I have to go to the left. And that means when I write my exponent, it's positive. Okay, I want the decimal here between the 7 and the 4. For that to happen, it has to go to the right. If it's going to the right, exponent's negative. Okay, I need the decimal to go between the number I marked and then the number right after it, right here. For that to happen, we're going to have to go to the left, and that means my exponent's positive. Okay, so those three things. Need your decimal. You need to spot the first non-zero number from the beginning. And then you have to decide if you have to travel right or left to get between that number and what's after it. Right will be negative, left will be positive. Okay, now move the decimal. I need it between the 3 and the 0. So 1, 2, 3, 4, 5. Okay. So now I write my decimal. Before it we have a 3 and then nothing but zeros, so I just don't ignore those. And afterwards we have a 0, but then there's a 2, so I need to write the 0 before I get to the 2. And it's times 10. And it's going to be a negative power, so negative. And now I count the digits between decimals. 1, 2, 3, 4, 5. So it's 10 to the negative 5th power. Now if you want to check your answer, what you can do is punch that in on your calculator. 3.02 times 10 to the negative 5th power. And does that look kind of like what we started with? Sure it does. I mean, before I wrote all that crap, that's exactly what we started with. So I did that right. Okay, next problem. We have to move to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes between those two. So here's a point, and before that we have 4. After it we have 6, and then nothing but zeros, so I don't write those. 4.6 times 10. Now the power here is positive, so I don't make a negative sign. And I count 1 between the decimal points, where I started and where I ended. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4.6 times 10 to the 9th power. Okay, next up. 58,000. Well, we said we were moving to the left. We have to get between the 5 and the 8. 1, 2, 3, 4. So I got my point. I have a 5 in front and 8 behind times 10. And power's positive, so I don't need the negative power, but I need a power between here and here. 1, 2, 3, 4. By the way, you can check these answers on your calculator. 4.6 times 10 to the 9th power. That looks exactly what I started with. 5.8 times 10 to the 4th power. Looks exactly what we started with, 58,000. Okay, next, 0. Remember, we need to move it to the right. So 1, 2, 3, 4. Guys, got to go between the number I marked and the number after it. So point, I got 7, and then 42. Remember, I don't need the extra zeros on the front or the end. Okay, now if there's 0 and then there's more numbers not 0, then we put it. But like here, I mean, there was a 0, but then there was a 2. So times 10, count the digits, 1, 2, 3, 4, 5. But it has to be negative 5 because whenever we have to move to the right, it's negative. If you want to check your answer. Now let's say I made a mistake and put positive 5. That's wrong because that does not look like the number I started with. I started with a really small number. There, again, I forgot to put the negative. There you go. Okay. All right. Next problem. Remember, you've got to move that decimal so it's between this number and the number after it. 1, 2, 3, 4. So I have my decimal point. There's a 3 in front with a bunch of zeros and then a 2. So 3.2 times 10. You always use 10. And you're like, why do you use 10? Well, because when I move the decimal place, every time I move it, that's a 10. If you move it twice, it's 100. If you move it 3 times, it's like 1,000, which is 10 to the third power. Okay, then negative, and then count the digits between here and here. 1, 2, 3, 4. So that would be negative 4. Let's check our answer. 3.2 times 10 to the negative 4th power. And that looks identical to what I started with. Okay, next problem. Remember, we have to get the decimal between this number and what's after it, a 0. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got my decimal, and you got 7. Now, after the decimal comes nothing but zeros. So I don't even need the decimal then in my answer. It's just the number 7 times 10. And positive, and then we're 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the power of 9. 7 times 10 to the power of 9. And you don't believe me, check the answer. Okay. It's a lot of zeros. Actually, 7 billion is the number there. Okay, the next one. 0.0000742. It's a really tiny number. Okay, well, we're going to move it to the right because we have to get between these two. Okay, and then before it we have a 7 and then a 4-2 after it times 10. Now, the right's negative, so we're going to make that negative and then count the digits between 1, 2, 3, 4, 5, 6. So 7.42 times 10 to the negative 6th power. Okay, and then last but not least, here's my decimal. We have to go to the left because we have to get between the 5 and the 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And since I had to move to the left, first let's get the number. You got a 5.6. You've shortened the number times 10. Left is positive, so I count the digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5.6 times 10 to the 9th power. Again, if you don't think those are the right answers, check them on your calc. 7.42 times 10 to the negative 6. Got that? That's exactly that one. 5.6 times 10 to the power of 9. Okay, exactly the same. Okay, now on the back side, they give you the number in scientific, and you need to write it out in standard form. Well, that's easy. You can just multiply that on your calculator. 2.3 times 10 to the power of negative 5. So that's going to be 0 point and then 4 zeros before we get to 23. Okay, that's what the number actually is. Really tiny, eeny-beeny number. Okay, now the exponent's positive, so I should end up with a pretty big number. 3.46 times 10 to the 8th power. Okay, you have 346, 0, 0, 0, 0, 0, 0. Now you're like, well, do I put the decimal? No, you don't need the decimal. Okay, what you want to do, though, is put commas between every 3. 346 million. Okay, 4.03 times 10 to the power of negative 7. And 0 point, and then you have 6 zeros. And then a 4, a 0, and a 3. Okay, now you don't put commas when you have 0 point. Okay, now no commas after the decimal. If there is no decimal, you need commas. Then 5.21 times 10 to the power of 4, 52,100. All right, guys, that's really all I have to say on that. I hope it's been informative and clears some things up.